apologize again for this misunderstanding from my side. Yeah, from my side, I'm going to give you a couple of words about SUREBRIDGE project. Just to give a little background about the initiative that we had in SUREBRIDGE and why we started all this. We know that we have a great demand for strength and repair of our existing bridge stock. Many of our bridges in our networks are approaching their, I would say, end of their lifespan or service life, and of course the extra loading and also the increasing demand that we have on our bridges and also the lack of resources that we have to maintain our bridges would have resulted in huge stock of bridges which are in deep need for strength and repair. Since mid-70s, already I would say beginning of 70s, major road owners and bridge owners, they started looking into more effective methods for actually strength and repair of bridges. With a keyword in their heads, short disruption or no disruption. So they were striving actually for finding methods which could actually cause a minimum disruption or interruption of the traffic. And since mid-70s, fiber reinforced polymer materials, which I would say they are a new class of high performance construction material, at least in civil engineering. They have been around for 60, 70 years in both industry and aviation industry, but for us, they are rather new. Superb materials with regard to mechanical properties, durability, they came into play, and they were introduced and they actually proved themselves as a sustainable, cost-efficient, and structurally effective materials and method for strengthening. So basically what we do, talking about the concrete section, could be a girder, could be a slab or whatsoever, which needs some strengthening or increase in the load-bearing capacity. We just come up with carbon fiber laminates. Usually we are talking about 1.2 to 2 millimeters thick carbon laminates, or and the width anything between 50 to 100 millimeters. We usually use a sort of epoxy material, as you see the green material here, put it on the surface, and then on the laminates we wait for a couple of days until it's cured, and then we have the structure strengthened. However, a limitation with this method is that you can easily over-reinforce the section, because those kind of structures that we are talking about, they usually have reinforcement corrosion, so they are highly under-reinforced. And in order to compensate for that, we should come up with a thin layer of actual concrete on the top, just to prevent crushing of the concrete. And that was basically the initiation of SUREBRIDGE idea. Also, there is one more thing. In the past 20 years, we have learned that by bonding pre-stressed CFRP laminates, instead of just putting them as passive reinforcement agents, we can get some extra advantages, like better serviceability, because we induce compression, tensile part of the structure, we close down cracks, we minimize the water infiltration and other chemicals, of course. We get better crack width control. And also we delay the onset of the reinforcement, plus some extra advantages that we get with regard to fatigue, which is becoming an issue nowadays by increasing the number of the axles on our trucks. However, there is a problem with this traditional, basically, way of inducing pre-stressed laminates. There is a huge stress concentration at the ends of the pre-stressing laminate, or the strengthening laminate, I would say. And we have to use a sort of mechanical anchorage. Yep. And the SUREBRIDGE is trying actually to solve this problem by putting forward a method for a pre-stressing method, which doesn't need anchorage, so we're not dealing with the long-term issues that we deal with in the traditional systems. So I would say in general, we are putting forward 4 major areas of innovation, I would say, in SUREBRIDGE. The first one is the tailor-made. So you remember the concrete deck or concrete layer on the top. We are actually replacing that one with a tailor-made FRP deck. The second area is basically combining the FRP deck strengthening from the top and carbon fiber reinforcement from the bottom to make actually this balance between these two so we can achieve any level of strengthening that we want without over-reinforcing. The third one is basically the pre-stressing system, anchorless pre-stressing system that we have actually putting forward. And the fourth one is basically the connection between the FRP and the concrete deck, and we are developing some concepts for using cement-based mortars to make this connection. And this is highly appreciated by a new technology called stay-in-place formwork, so that we have basically FRP formwork which actually act later on as reinforcement. So some implementation, or basically what we think SUREBRIDGE might actually fall in place. And the great thing with SUREBRIDGE is that not only all components actually work together, individually components that we are using in this project, they work well. The very first example is a bascule bridge in Sweden, which was just refurbished by this tailor-made concrete FRP decking system. The project was done just last summer. I'll give more information if you are interested. The pre-stressing system that we have developed, it's an older version, but already 2 bridges and a couple of buildings have been actually strengthened using this. The third one that I mentioned is the stay-in-place formwork, which is actually getting more and more demand on the construction market. So this is basically what SUREBRIDGE is about in 5 or 7 minutes. And if you're...
Yeah.
Sorry?
7 that was reasonable, thank you.
Yeah, thank you.
Very long final minute.
Good.